So we are essentially taking factoring from chapter 5, solving polynomials from the beginning of this unit, and mashing them all together into one review day. Remember that if something cannot be factored, we call it prime. So a prime polynomial is something that simply cannot be factored. Today we're going to learn a factoring strategy in which we take a quartic or a 6th degree or an 8th degree and we rewrite it as a quadratic. So we're going to use this thing called quadratic form where we rewrite an expression so that it looks, oh my goodness, like a quadratic. And we represent the x's with a variable u. So like 12x to 6 plus 8x to cubed. Whoops. Can be rewritten as 2x cubed plus quantity 2x cubed plus 1. Where that u representation is for 2x cubed, and this acts as 3u squared plus 2u plus 1, and then you would factor that. So, like I said, we're going to review all our factoring strategies throughout this topic. One of our first strategies was GCF. So, again, you don't have to write down all of these examples. I would focus on writing down my important formulas. But if you know what the GCF represents, then you're good. Now, if there are two terms, we have three special formulas, a difference of squares. Now, a new one is called a sum of two cubes. If you have two cubes being added together, then you can write that as a plus b, where a and b are the cube root of those cubes, times a squared minus ab plus b squared. And again, if for any of you that doesn't have to do this in your textbook, you could always go there and take a picture. You can also take a picture of my board. In case you took pictures. But these are just strategies, formulas, and techniques that help you throughout the course of this unit. If you have a perfect square trinomial, then it always factors as a plus b squared or a minus b squared. Perfect square trinomials are going to give you repeated roots. Perfect square trinomials are going to give you repeated roots. General factored form looks like that 3 factor. And then factor by grouping is if you have 4 terms, then you want to take the GCF out of each. So again, factor by grouping is if you have 4 terms. Yeah, and I think up and down, up and down. I promise after like that slide, it's not a lot of writing. If once you're done copying that slide, you flip it over and you want to start looking at the problem and being like, oh, I know how to do that. And start applying your techniques. Okay. I felt that. I don't want to like. Yeah, that was me yesterday. Like I felt like such a space for that. I was like, neat. Alright. So 16x sub 4 plus 54xy cubed. When I look at this problem, the first thing I see are 2 terms. The second thing I see is that both terms have an x, and both terms have even numbers. So 2 terms, both containing similar variables, the first thing I'm doing is taking out a GCF. So looking at 16 and 54, both divide by 2. Let's take a 2 out. Both have an x. Let's take an x out. That leaves 8x cubed plus y cubed, and then 54 divided by 2 is 27. 27 and 8 are both perfect cubes because 8 cubed is 2 cubed, 27 is 3 cubed. They're being added together. So if you flip backwards and you look, you now have a sum of cubes. So after taking out our GCF, we have a sum, because they're being added, of cubes. So we're going to apply our new formula that says the cube root of the first, so the cube root of 8 is 2, cube root of x cubed is x. This sign stays the same. Cube root of 27 is 3, cube root of y cubed is y. So you get 2x plus 3y, and then the remaining part of the formula, I'm going to smush this way a little bit, is a squared. So a is what I wrote here. So 2x squared becomes 4x squared. Opposite sign, so minus a times b, so 2 times 3 is 6, xy, plus, so the signs are opposite for this one, b squared, which would be 9y squared. A sum of cubes will not factor further. Like this will never be further factorable. So if you use the sum of cubes formula, that second part will never factor further. Does that make sense? It's like people try to factor this. I'm like, it doesn't factor. So you're done. 9y cubed plus 5x cubed. You see this and you go, 9. But that's a perfect square, not a perfect cube. So 9 and 5 are not perfect cubes. Y and x have nothing in common, no GCF. Oh crap. Once you see multiple terms, so in this case I have 6, you're thinking factor by grouping. So you want to start looking for common variables in case you need to rearrange your terms. So x, 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 y, y, y. So I'm going to do my factor by grouping, where I group the first 3 terms because they all have an x, and then group the last 3 terms because they all have a y. So my GCF is going to be that x or that y, and then possibly some numbers. 8, 4, and 4 all have a GCF of 4. We already decided they all have a GCF of x. So that leaves 2a plus b plus c. 6, 3, 3 all have a GCF of 2. And y, that leaves 2a plus b plus c. Wow, no. 2 there, 3 there. Sorry about that. That gives a factor by grouping GCF of 4x and 3y. And then what matches or stays behind is the 2a plus b plus c. So your final answer is 4x plus 3y times 2a plus b plus c. A second factor by grouping. So again, you're looking to identify similar or like variables. We have an F, a G, an H, a G. So, all right. I have a G here and a G here. An H and an H. A Y, a Y, a Y. A Z, and a Z. So what I'm going to do this time is factor by grouping, but I'm going to do it a little different. I either want to get all the Z's each other and all the y's to be near each other because I have 3 z's and 3 y's. Or you would have to do factor by grouping where you had the 2 yellows, the 2 purples, and the 2 blues near each other. So you either need to have all like the same variables or all, mixed. So I could do 3 or 2. What I'm going to do is flip the y and the z term here. And I'm going to group the first 3 to all have y's and the last 3 to all have z. So you have 20fy minus 10hy plus 15gy plus 8hz minus 16fz minus 12gz. So again, that way I have a GCF of y and a GCF of z as well as their numbers. So 20, 10, and 15 all divided by 5, leaving 4f minus 2h plus 3g. And then here I have a positive 4f. So I know that I need this to also be a positive f. So I'm going to take out a negative 4z. And that will leave me with a positive 4f, a negative 2h, and a positive 3g, thus making my inside parentheses match. So I have 5y minus 4z, 4f, 2h, 3g. So not every problem is in perfect order. Sometimes you have to rearrange your terms to get them to be nice and factorable. X to the 6th minus y to the 6th. So now I have a difference, because they're subtracting, of cubes, because x to the 6th is really x squared times x squared times x squared. So I have 3x squared. So I'm going to apply my difference of cubes formula, where it's x squared minus y squared as my a and my b. That makes this x to the 4th. Y to the 4th, because a power to a power gets multiplied. And then my middle is to multiply those two terms together. So always the opposite second sign here. So it'll be x squared, y squared. And then the last term is always positive. But then if you look at this right here, that is a difference of squares. So it's going to actually factor again as x minus y, x plus y. So you have a difference of squares within your difference of cubes. So a cubed, a cubed, a cubed, b cubed, b cubed, b cubed. So once again, we're going to do factor by grouping. So we'll take out our GCFs of the first three, GCF of the last three. Again, you took out a negative b cubed, so it changed the signs inside. Once again, creating a difference of cubes out in front. And leaving you with a special formula right here. So x squared minus 6x plus 9 is a perfect square trinomial. So that's going to factor as a repeated root with x minus 3. And then we're going to apply our difference of cubes formula on a cubed minus b cubed, giving you a minus b, a squared, plus ab, plus b squared, and then, like I said, as we get into the week and later, we'll start finding the roots from